tutorial on induction. Induction is the last tutorial for this summer course. Inshallah, after the lab directly, I will post for you the final homeworks grade in my Excel sheet. So just verify if these data similar to what you have on a Blackboard. Maybe there is a mistake. But it is not the chance for reviewing the homeworks again and again because I post for you every time the key solution with mark distribution. And the average of overall homeworks, all the homeworks, the average of them is better than what I expect. Um, so today we will have tutorial on induction. There is no homework for this tutorial, just tutorial. Let me share with you my files, and this file is already available on Blackboard. Before I start solving exercises with proof by induction, what is a proof by induction? Actually, induction is an assumption said if this is correct for n, then it is correct for n plus 1. And it's like a recursive. There is a base case, which is the smallest element in your domain. If the domain is just z, you cannot prove by induction. You have to divide two cases where is a small element in their domain, so there is a base case where you can stop. نفس طريقة الريكيرسيف. Okay, but it's somehow like recursive. It is not a recursive. Okay, there should be a base case. Should be a small element that you check this is true for that element. Then you have a conditional statement said if it's true for n, then it's true for n plus 1. This if statement will be proved directly. Direct method اللي احنا خديناها. We assume the premise, we have to show the conclusion. If you think about the induction in this way, you can easily solve whatever the problem is. In this tutorial, I will discuss 3 different kinds of a question. Usually you will get one of these problems, but we can use the induction even with different problems. The first kind of problems is summation problems. Summation أو ممكن يكون product. The symbol of summation هذا هو summation from I equal 1 to n. لو product يجي علامة الباي الكبيرة بعد again from I equal initial value to maximum value. The difference between summation and the product إن ديك عبارة عن product multiplication. Here it's about summation. When I say summation from I equal 1 to n for any given term, it means I will substitute with 1 here, plus substitution with 2, plus substitution with 3, and I will stop when I reach a substitution of n. So I continue accumulatively adding terms till I reach n, which is the last term. البرودكت اللي تجي على شكل باي ديك عبارة عن multiplying the substitution of all terms from a given I initial value till we reach the stop of I. Now, if I want to solve by induction, سواء كان summation أو كان product, how to do the steps? قلنا احنا the first step is البيس. This is step number 1. You should check البيس condition. If it's true, you can continue. If the base falls, معناته you cannot prove by induction. So the first step, you have to check the base case, where I can determine the smallest element, which is my base element, from here, for n greater than or equal to 1. So the smallest element in my domain is 1. I will check if this is true when n is equal to 1. How to check that? For such kind of problems, أحسب left hand side وأحسب right hand side, and then we compare. if we get the same value or not. What is the left-hand side here? It's mean this side. The summation from 1 to 1. Why? Because the n is equal to 1. So I have to substitute for this from 1 to 1. مو لازم يكون from 1 to 1. For example, لو كان هني n equal greater than or equal to 3. So the base will be when n equal to 3. So I have to find the summation from 1 to 3. Okay, here from 1 to 1, there is only one iteration, which is 2 times 1 minus 1, which is equal to 1. لو كان عندي from 1 to 3, I have to find out the result of 2 times 1 minus 1 plus 2 times 2 minus 1 plus 2 times 3 minus 1. So I have to find what is the summation from 1 to 3. Here in our case 1, so there is only one iteration. من بعض الأخطاء اللي الطلبة يواجهونها, the most common mistake, they assume here n is equal to 1, whatever the base mentioned in the domain. أو بعض الأحيان حاطين الدومين مثلا 3, يجون يحطون n equal to 3, they say substitution from 1 to 3, they just substitute here with 3. No, you should find all the addition, all summation accumulatively from 1 to 3. Okay, so here because we have just only one iteration from 1 to 1, معناته I have to substitute here only once, so I get 1. We finish from the left hand side. We have to find out the right hand side. Right hand side, n square. In our case, n is equal to 1. يعني 1 square is equal to 1. We find in the left hand side is equal to the right hand side, so it is correct for the base. This is how we check the base step if we have summation. We have to find out the left hand side, right hand side, and then compare between them. If we get the same value, whatever the value is, معناته it's true for the base case. We finish from the base. Now we are ready for the inductive step. The inductive step said, if this is correct when n equal to k, then we can say that this is also correct when n equal k plus 1. معناته, if we want to prove it directly, we assume it's true when n equal to k. يعني we are assuming that this is true from I equal 1 to k. So just remove n in this term and replace it with k. From I equal 1 to k, the term 2i minus 1 is always equal to k squared. So I am assuming that this is true. My goal is to show that it's also true when n is equal to k plus 1. So my goal is to show that the summation from I equal 1 to k plus 1 for the term 2i minus 1 is equal to k plus 1 square. Now, my goal is to show this, so I have to prove this. How to prove it? What is the summation? Direct proof. يعني I will start from the left hand side and try to simplify it to reach the right hand side. What is the summation from I equal 1 to k plus 1 for the term 2i minus 1? It's the substitution from 1 to k plus 1 inside the term 2i minus 1. يعني it's equal to 2 times 1 minus 1 plus 2 times 2 minus 1 plus 2 times 3. And I will continue till I reach k plus 1. But actually, before I reach k plus 1, there is k. لأن they are coming in sequence. أكيد ال k plus 1 قبلها k. So I will write 2 times k minus 1 plus 2k plus 1 minus 1. So actually, this is the equivalent expanded form of the summation. what is the summation from this term to that term? This is all equal to the summation from I equal 1 to k. This is the expanded form for this term plus 2k plus 1 minus 1. دائما لما يعطيكم summation السميشن from I equal 1 إلى k plus 1 عبارة عن السميشن from I equal 1 إلى k plus substitution of k plus 1 in this term. مو لازم تكتبونها في expanded form. I'm just showing to you the idea. You can easily come from here to there directly. Remember, why I choose from I equal 1 to k? Because this is my assumption. You have to use the assumption in your inductive step proof. لازم استخدم الاسsumption. إذا حليتها without using الassumption, this is not inductive. So I have to use the assumption. So I will try to find out a relation between my goal that I should prove with what I have here in the assumption step. إذا كانت البروبلم summation فدائما أحط في بالي what is the relation for my goal with the assumption. فإذا كان مالي from I equal 1 إلى k plus 1, this is my goal that I have to prove. It's equal to the summation from I equal 1 إلى k plus substitution of k plus 1 here. يعني أشيل I وأعوض k plus 1 اللي هي بتصير عندي 2 times k plus 1 minus 1. Now from the assumption I know that in summation from 1 to k is equal to k square. So I will just remove this and I will put k square instead of that. Plus, I will distribute it 2, so I will get 2k plus 2 minus 1, which is equal k square plus 2k plus 1. This is a perfect square of k plus 1 all square. So I prove it. This is one kind of a problem اللي هو summation problem أو البرودكت نفس الطريقة بالضبط في comparing مال البيس you have to calculate the left and the right and then compare the result. Then you have to put inductive steps and always the summation from 1 to k is equal to the k plus 1 equals summation from 1 to k plus substitution of k plus 1 and then you can do some mathematical steps. Another kind of a problem, this kind of a problem, a divisibility. Prove by induction that a minus b divide a to the power n minus b to the power n for n is greater or greater than or equal to 1. احنا قلنا divide يعني we can write it in a different way. هاي النوتيشن divide, this is not a division. هاي vertical line أقراها divide. So when I say that a minus b divide a to the power n minus b to the power n معناته إن a to the power n minus b to the power n is something divisible by a minus b. يقبل القسمة على a minus b. How to represent that? أعبر عنها a minus b times an integer value. You can give it any symbol. Here I put w. W should be integer. So this is exactly a divide. أقدر أعبر عنها this statement, which means a minus n, a to the power n minus b to the power n is something multiple by a minus b or divisible by a minus b. So we can write it in this way. Now I will start the inductive steps. The first is the base, where n is equal to 1. From where? From here. I decide that the base is equal to 1. Then I will substitute now. How to solve such kind of problems? هناك كنا نحل left hand side, right hand side ونقارن. Now here there is no left-hand side and right-hand side. We will check. We will get a true value, true or false. So I will substitute in this one, in this definition, to find what is a to the power 1 minus b to the power 1. A to the power 1 minus b to the power 1 is equal to a minus b, which means a minus b divisible by a minus b. Yes, because w is equal to 1. يعني a minus b divide a minus b. لما أقبل القسمة عليه يعطيني I can find w as an integer value معناته it is divisible by a minus b. And this is what we get here. So it's just true because w is an integer value. هني ما عندي right hand side و left hand side and comparison. Okay? So we have to check if this condition true or not. It is divisible by or not divisible by. We find that it's true for the base. So here we will move for the inductive step. In inductive step عندي شغلتين. I have to assume and I have to show. قلنا inductive عبارة عن implies statement. We prove it directly. Directly معناته we assume it is correct when n equal to k. We have to show that this is also correct when n equal k plus 1. Now, when I assume that this is true when n equal to k, معناته I have to substitute here. In a to the power k minus b to the power k is something multiple by a minus b or divisible by a minus b. My goal is to show that a to the power k plus 1 minus b to the power k plus 1 is also divisible by a minus b. يعني I can write it in a form of a minus b time an integer value. Here I give it the symbol f. Now, this is our goal. Directly في equal معناته from left I try to simplify it to reach right. So I will start from left hand side. What is a to the power k plus 1 minus b to the power k plus 1? How can I simplify it in such a way that I can reach my goal? Something multiple by a minus b. Remember, you should always use your assumption. Mathematically لما يكون عندي plus في الباور, this is can be written in a form of a times a to the power k. يعني هاي البلس عبارة عن the same base بينهم multiplication. هاي مو dot, هاي multiply. Okay? So when I say a to the power k plus 1 عبارة عن a times a to the power k. So when we have the same base, we add the power. فلما يكون عندي addition في الباور I can put it in this form. So this is can be written like this. A times a to the power k minus b times b to the power k. Now, how can I use my assumption? Do you have an idea? What do you think? How can I get a to the power k minus b to the power k? يعني شلون أقدر أحصل هاي الأسامبشن هني. I find it so I can substitute. Not must that you can use your assumption in this way. لازم استخدم الاسامبشن بس هل اقدر استخدمها بهاي الصورة؟ مو لازم. It's not a must. So what I will do, if I try here to find something common between these two terms, actually there is nothing common except الباور. يعني ما أقدر أخذ A عامل مشترك لأن ال A is not a factor here. And I cannot take A to the power K because it is not also here. So what will happen? I'm stuck. So in this case, Instead of finding a to the power k minus b to the power k, I will just rewrite the assumption. يعني راح أطلع what is a to the power k in my assumption. يعني هي الفورمة اللي أعطيني إياها إن a to the power k minus b to the power k. أنا مو قادرة أستخدمها مثل ما هي هني. So what I did, just substitute here what is a to the power k from my assumption. It's equal to a minus b times w plus b to the power k. So I will use my assumption, but in this way, in this form. Here I will remove a to the power k and I will substitute with its equivalent from the assumption. فأني استخدمت الassumption but I am just rewriting it in a different way and then use it. Then I will distribute A. فبيصير عندي A times W times A minus B plus A times B to the power K وما أنسى minus B times B to the power K اللي موجودة أصلا من البداية. Then if you look over these two subterms, you will find that B to the power K is common between them. So I will take P to the power K as a common factor between these two subterms. I get A minus B. So here the whole parenthesis A minus B موجودة هني and it's also there in the first term. So I can take A minus B as a common factor between these two subterms. The common or the remaining part is A times W plus B to the power K. Now, is this integer? Yes, it's integer because the W is already integer from the assumption here. So A times integer plus B to the power K is always integer. So I can put F, where F is equal to A times W plus B to the power K, which is belong to Z. So I prove it by induction. This problem is different than the first one, only with checking the base, whether it's true or false. And here we have small trick that not always you can use your assumption as it is. You can rewrite it in a different way and then use it. But the most important thing is that you are using the assumption in your proof. استخدمت الاسامبشن مالي بس مو بالصورة الاعتيادية. I'm just rewriting it. بس نفس الفكرة إن عندي base عندي inductive step. في inductive I have to assume, I have to show, and these are very important to write them very clear. The last type of problem اللي هم series problem. وبتلاحظون في series problem that you have two definitions with two domains. Which one is my question? If you read such kind of problems, you will find keyword given. Given معناته it's already true, it's already proved, no need to prove it. This is not your problem. What is the difference between this definition and that definition? A series عبارة عن elements following each others. But these elements in the list or in the series, they are related to each other. مو أرقام وبس. So here we have a definition نسميه recursive definition. Recursive أعطوكم إياه في البروجرامينج جافا 2 إن الريكيرسيف معناته the method is calling itself. صح؟ بتلاحظون في الديفينيشن هني to calculate tn you should calculate tn minus 1 يعني كأن you are calling the same method with n minus 1 as a parameter. To calculate T10, you have to calculate first T9. To calculate T9, you should calculate T8. And to calculate T8, you should calculate هذه الطريقة نسميها recursive. Every term depend on the previous term. When I will stop when I reach T0 because T0 is the base case in my recursive definition. فتتخيلون لو بحسب T 1000 لازم أسوي call from 1000 to T0 to stop, and then accumulatively I will calculate the term. Recursive definition. وهذا recursive definition will consuming my computing time خاصة في big numbers. فاحنا دائما في البروجرامينج ناخذ الالجوريثم الباينوميال we prefer it لأن it will minimize the executing time of the program. If I want to find out Tn with this binomial definition, just T1000, I will substitute here. There is no need to calculate 1,000 terms. Now we are in discrete mathematics. We are not on an algorithm courses. So here, the purpose is that I want to prove that this binomial definition will give me the same series with this recursive definition. This is the question. Given to you a recursive definition for a series, and the question for you is show that this given binomial definition is equal, it will give me the same series with this recursive definition. يعني T1000 هني بيطلع نفس T1000 في recursive definition. T1 million بيعطيني نفس قيمة T1 million there. الديفرنت ان الاكسكيوشن تايم حق هذا اسرع من هذا في الكمبيوتنج تايم. الحين احنا ك discrete mathematics, the purpose of this question is to check that this series is equal to the above recursive series. بس أنا أعطيتكم المقدمة اللي في البداية عشان أخليكم تفرقون ما بينهم. Now your question is this one اللي عقب كلمة show that. This is your question. You will work on this definition, not on the above definition. But you will use the above definition in two steps, okay? In two places. And I will show you where to use and how to use the first definition. So the one of the common mistake done by the student when they decide what is your pace. My pace when n is equal to 0. Why? Because this is my question. Here it said n is greater than or equal to 0. One of the common mistake that the student assume that this is their assumption, that n is equal to 1, and this is incorrect. مجرد تعوضوا لي هنا n is equal to 1, automatically this is incorrect and I deduct mark. Because your question is this one, not the above definition. So my pace will be when n is equal to 0. Remember, this is your question, not the above one. Now, if I want to substitute, I have to substitute here. What is T0? T0 is equal to, then I will substitute. Instead of n, whenever I find n, I will replace with 0. I will get as a result 5. Now, is this true or false? How can I check? I will go to the given series and I will check T0 is equal to 5 or not. Because I know that this is given to me, it's true. I have to show that this is equivalent to the above one. So T0 here is equal to T0 here, if they are equal series. So I will use the first definition just to check the pace value. T0 5, I go there. T0 is 5, yes, it's equal to 5. It's written to me directly. لو كانت مو direct, I have to substitute recursively and find it. So we use the first definition to compare if our pace is it true or not. This is the first usage of the recursive definition. Now it's true, I will move for the inductive step. The inductive step, again, I have to assume it's true for n equal to k. I have to show that this is also true when n equal to k plus 1. Which one? Remember, you should substitute here. Never substitute there with a recursive definition. هذا هو السؤال مالنا. فما أروح أعوض فوق. I have to substitute here. This is my question. So when I say I am assuming it's true when n equal to k, معناته here just remove n and put k. I am assuming that tk is equal to 9 minus 4 times, this is time, not 4 point, okay? 4 times 2 to the power k plus 3k square plus 6k, where k is greater than or equal to 0. This is my assumption. I have to show that this is also true when n equal to k plus 1. Again, I have to substitute here. Instead of n, I will put k plus 1. My goal is to show that this term is equal to this value. Directly وعندي equal, so I will start from the left hand side and try to reach right hand side. What is tk plus 1? How can I simplify tk plus 1 to be this term? So here, to start my loop, I need the first definition. قلنا first definition هذا الريكيرسيف راح نستخدمه في موقعين في الحل. First usage is to compare if my step 1 اللي هو البيس true or false. فأشوف قيمة البيس هني مع قيمة البيس هني. If I get the same value معناته it's true. So this is the first usage. The second usage of a recursive definition to start your proof. You want to find what is tk plus 1. So from here, what is tk plus 1? You will go instead of n, you will put k plus 1. ف 2k plus 1 يساوي 2 times tk plus 1 minus 1 اللي هو tk الترم اللي قبله minus 3 times k plus 1 minus 1 all square, which is 3k square. So I start my proof from the recursive definition. Then I will forget the recursive definition. I don't care about it now. My goal is to substitute now, and I use my assumption to try finding a right-hand side. What is tk? Tk from my assumption is equal to this term. So instead of tk, I will remove it and I will write its equivalent from the assumption. فراح أشيلها وراح أعوض. Then I will distribute 2. ف 2 times 8 18 وهني بتصير عندي 4 times 2 to the power k time 2. هذولين مو dot, these are multiplications, plus 6k square plus 12k minus 3k square. Look over your goal here. You have 4 times 2 to the power k plus 1. And here we have the same base 2 and 2. They are multiplied, so I can add the power. Okay, so I will get 4 times 2 to the power k plus 1. So I finish from this term. I get it already here. Here we have 6k square وهنا عندي minus 3k square. So I will get 3k square as a result here. الحين نجي نبي نطلع الباقي. How to do that? عندي هني plus 12k وعندي هني 18. Actually, the constant value here is 9. So 18 is equal to 9 plus 9. أو أقدر أقول 9 plus 6 plus 3. So I will put 9 plus 6 plus 3 distributed. Why? Because I want to get these terms here. So what I will also split 12k أخليها 6 plus 6k plus 6k. Then I will take a 6 as a common factor here. So I will get I will work on these two together, and I will work on these together. Here, I can take 3 as a common factor. Here, I can take a 6 as a common factor. What is left here is k squared plus 2k plus 1, which is a perfect square of k plus 1 square. So we get it. We get the right-hand side as it is. Some students, they may feel it's difficult to do that. So usually in my homeworks, I accept from the student to simplify this here and show me all the steps, and they will reach to specific step here, and then they simplify it to reach the same step there. But my advice, some instructors do not prefer this kind of proving. So whenever you simplify this and you reach to specific step, here you reach the same steps. So just rewrite the steps in reverse order here so you get the same result. Okay, most of them, they prefer that you reach from left to right hand side in your proving. So whenever you have something with recursive or with series, you have recursive definition and binomial definition. Remember, your problem is the binomial, not the recursive. So all substitutions should be with the binomial definition. Even the base, you should check the base with the binomial definition, not with the recursive definition. You will use the recursive just to compare if you get the correct value in the base. You will compare your base value with the base in the given series, recursive definition, and you will use the recursive definition to start your proof. One of the common mistakes done by the student, they substitute here with the recursive definition, and that will make them stuck. Never they go outside the circle. Is that clear? So here في الاندكشن احنا مرينا على 3 أنواع من مسائل, and we see how we apply the inductive technique on these kind of problems. As a challenge for you, I will give you this series. Try to solve it yourself. It already موجودة في السلايدز على البلاكبورد. Try to solve it yourself and see if you can do it or not. If you need any help, you can send me direct message to correct for you your answer. Try to solve it on a piece of paper, capture this paper and send it to me. It's not graded, just to practice. Do you have any questions? Do you have any questions? This is the last tutorial we will have together. And as I said at the beginning of the tutorial, I will post for you your marks for homework 1, homework 2, and homework 3 on a team channel. Just compare if this mark similar to what you have on a Blackboard. Okay? And then if there is any mistake, just inform me about it, because I will send your marks to your instructor, Dr. Harrat, inshallah, by Sunday, not more than Sunday. Thank you very much and wish you all the best.